Okay, so it is September 23rd, it's Wednesday. This is our B-Day AP Stats, and we're gonna start today's lesson with doing one of these problems in our Can You Do number 4. So we're actually gonna go in, turn the page and do number 46, so it's on the back of the first page. So this problem is about the caffeine content in carbonated beverages. So the U.S. Food and Drug Administration limits the amount of caffeine in a 12-ounce can of carbonated beverage to 72 milligrams. For an 8-ounce beverage, that translates to 48 milligrams. Data on the caffeine content of popular soft drinks in milligrams per 8-ounce serving are displayed in the stem plot. So number 1 wants to know why we split the stems. And in our notes that we have that go along with stem plots, we have written that you split stems to see the shape of the data better. So if you look at the stems on number 46, they only go from 1 to 4. And that set of data is so small, like there's only 4 stems, that if we split the stems out, that's going to make it so that we can see the shape of the data better. Just to remind you, the reason that the numbering is weird is because these are the actual problems from your textbook if you ever wanted to get into your textbook and look at them. So why split the stems? Because, or so we can see the shape of the data better. Give an appropriate key for this graph. So I'm just going to choose one number. I think I'm going to choose 37. And I'm going to say 3 bar 7 is 37 milligrams. And that would probably get you full credit, but I'm going to be really specific. 37 milligrams of caffeine. If we were being super extra, we could say per 8-ounce. And I know that that's the key because up here it's talking about how the maximum amount for an 8-ounce can is 48. So I know that that's how I'm supposed to read this stem and leaf. Okay, so the reason that I wanted us to come here is because I would like to find the median of this stem plot together. So the first thing that we have to do is see how many beverages we looked at. So we need to find N. So I'm just going to count them up on the paper. Okay, I'm getting 38. How about you guys? Okay, so now to find the position of the median, I can use that formula that we learned last time. That's going to be 38 plus 1 divided by 2. You guys are going to have to tell me because I can't do that in my head. Good girl. You're fine. What'd you guys get? Okay, so first thing, because I did see this on some of your guys' quizzes, this is not the median. This is not your value of your median. This is the location or the position of your median. And what this is telling you is that your median is between the 19th and the 20th observation. So we start on the left-hand side and we count toward the right until we get to the 19th observation. So I'm getting that the median is right after the third 8. Is that what you guys are getting? Yes? Okay, notice that is not 19.5. The position of your median tells you where it's at. It does not tell you what it is. This tells you where. Okay, so what I saw on a lot of quizzes was now people would write the median is 28.5. Is that true? No, it is not true. Your median is between the number 28 and 28. There is nothing between 28, which means your median has to be the number 28. If you're using the formula, you would do 28 plus 28 divided by 2. That gives you 28, not 28.5. So this is the where, this is the what. It is at position, the position between 19 and 20, and it is equal to 28 milligrams. So those were 2 common misconceptions that I was seeing on the quizzes that I've looked at so far. One, we got to make sure that we know that the POM, the position of the median, gives us the where it's at. And then we have to pay very careful attention to what the median is actually between if we're in that kind of a situation. Are we okay on this problem? Yeah? Okay. So while we're here, maybe let's use this as an example to talk about how we would find the quartiles. So the video that was our homework was on quartiles, and this time it was only like 11 minutes long. Hallelujah. So we talked about on finding the quartiles, it's like finding the median twice. So once you find the median, you ignore the right-hand part of the data and you find the middle of that half. That gives you quartile 1. And then you do the same thing for the upper half of the data. You cover up the median and the rest of the data, and you find the middle point between the upper half of the data. So if I go back to my stem and leaf here, I'm going to count how many observations are to the left of my median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there are 19 observations to the left of my median. I can find the middle of those observations by using this formula again if I wanted to. So I would do 19 plus 1 divided by 2, and that is going to give me 10. I'm not going to label this because it's not the position of the median, it's the position of Q1. So I guess we could label it that if we really wanted to. So now all we have to do is count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is the first 5 on the 2 stem, the upper 2. And now I'm just going to verify that I did that right. So to the left, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 observations. And to the right, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. Which means to find quartile 3, I just need to count 9 observations to the right of the median. 1, 2, 3, 4, 5, 6, 7, 8, 9. So quartile 3 is the 10th position, or the upper 3 stem, and the last 5. And if I kept counting, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 observations in each quarter of my data. So hopefully it's making sense that finding the quartiles is like finding the median twice. I'm going to write these down. Quartile 1 was 25, and quartile 3 is 35. Are you guys okay? Yeah? Okay, so we went through and learned how to find median, because center is something that they always want to know when we're asked to describe a distribution. And then we had to use that skill to learn how to find the quartiles, because we need to know those in order to determine if an observation is an outlier. So that's where we're going next. We're going to this outliers page with the pumpkins on it. So we know that outliers are data points that are far away from the rest of the data. But how far away from the data do they need to be in order to be classified as an outlier? So this is the actual shoe ownership for 52 of our teachers at Cypress. I sent out an email and asked them to tell me how many shoes they owned, and 52 teachers replied. These were the results that I got. These are the same numbers that I had you enter into your calculator. So we can see here that most of the teachers owned between 0 and 20 shoes. And then past 20, it spreads out a lot more. So for me, just looking at it, I feel like these two might be outliers. I mean, they're not that far away from this 48 and 47, or 47 and 46, whatever these are. But this is the point at which I start thinking, yeah, that might be an outlier. I think this guy is probably an outlier. And I'm pretty sure these last two at 100 and 102, I'm pretty sure those are outliers. And when I say outliers, I mean mathematically determined to be outliers. So if we're going to be able to say whether or not something is officially an outlier, we have to have some method for finding out how big is too big. The reason that we're interested in this is because these outliers really affect our data. So if we just looked at these data values, I would say that the average shoe ownership is probably around 15, 16, 17. Like most of the teachers are about right here in the middle if you average them out. It's definitely, the average is going to be lower because most of them are between 0 and 20. Does that make a little bit of sense? Yes, no? But if all of a sudden I decide to include all of these outliers, that's going to take my average that was probably around 15 and stretch it out so that it's probably more down here at like 25. But if you look at that, not very many teachers actually own 25 pairs of shoes. In fact, most of them own less than that. But these data values out here are making it seem like teachers own more shoes than they do. because when you find an average, you have to take all of the data values and divide it by the number of observations. So if my data values, if I only looked at where most of my data values were, my average would probably be around 15. But if I have to consider all of these extra teachers who have a lot of shoes, that's going to drag my average up higher than it should be because these points are unusually large. Does that make a little bit of sense? Are you sure? So most teachers have between 0 and 20, but our average is going to be higher than that because these guys' numbers are going to pull that average farther out than it should be and make it seem bigger. That's why we care and we note whether or not there are outliers in a data set, because if there are, it makes your data set seem different than it really is if you only give the average. So if we're going to find out if it is an actual outlier, we use the 1.5 times IQR rule. We use the 1.5 times IQR rule. Well, IQR is not something that we have even talked about at this point. You will have a worksheet that goes into this more in depth when we make box plots, but IQR is called the interquartile range. So down here underneath this box, I'm going to write down what the IQR is. It is your third quartile, subtract your first quartile. It is your interquartile range. So what this is asking is, how far spread out is the middle part of your data? How far spread out is the middle 50%? Range asks you, how far out is the data, all the data values? What's the difference between your max and your min? But interquartile range just wants to know the distance between the middle observations. So just to make sure visually we understand, range would be how far from the lowest value to the highest value. Interquartile range is how far from the middle, from the quartile 1 to quartile 3, or the middle 50% of your data. Does that make a little bit of sense? When we're finding outliers, we're only concerned about this middle 50% because we don't want to have to take into consideration all of these points out here that are really unusual. So finding the IQR is going to help us kind of work around the fact that we have a bunch of points all the way out here. Okay, so the rule is if an observation is an outlier, if it falls below the lower bound, and then it gives you the formula for finding the lower bound. It's an observation if it falls above, it's an outlier if it falls above the upper bound, and then it gives you the formula for the upper bound. So I just want to highlight a couple of things on that formula. The lower bound uses your first quartile and then it subtracts 1.5 times IQR. And the upper bound uses your third quartile and it adds 1.5 times IQR. So these boundary values are going to tell us how big is too big. At what point do we say something is officially an outlier? Or how small is too small? So this is the reason why I wanted you to find the quartiles for the pumpkin data, because we're going to determine if any of the pumpkins in the carving contest were outliers. So students bought pumpkins, and before they started carving, they weighed the pumpkins. If you were to find the quartiles, you need to order the observations from least to greatest, and then you find the median and then the quartiles. So if you didn't, or you did and you want to double check, quartile 1 should have been 4. The median is 6.6, and quartile 3 is 12.7. That makes it so that 1, 2, 3, 4, 5 observations are in the quarters. So if you count them, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, so on. One really good question that I got last class period was, do significant figures matter? Meaning, I didn't write 4.0 here, I wrote 4. That's okay if you just write 4. I didn't write 4.0 or 6.0 because I knew that I wasn't going to have enough room to write all the numbers out if I did. Are there any questions on finding these quartiles for the pumpkin data? Okay, JJ, are you shaking no, or are you just shaking your fancy hairs? You have the best hairs of all the kids. Okay, so now let's use these quartiles to figure out if any of our pumpkins are outliers. So the first thing I'm gonna do is find my IQR. That's Q3 minus Q1. So Q3 was 12.7 and Q1 was 4. So we're going to subtract those. And what do we get? If you're at home, you should be subtracting these two. Okay, be subtracting. What'd you guys get? Thanks, Ivani. Thanks, guys. 8.7. Okay, so now I'm going to find my lower bound. And after this problem, I just write LB and UB. But just so I have one example where I write everything out, I'm going to write it out on this one. So my lower bound, the lowest my number can be, is quartile 1, so 4, subtract 1.5 times IQR, which is 8.7. Okay, what do you guys think? Or what did you get, I should say? The classroom down the hall was playing the Jeopardy music so loud this morning. Is it Jeopardy? Doon, 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 doon. I feel like that stressed me out so hard. I would not be able to calculate. What'd you guys get? That seems too big. Did you minus? What'd you get, Haley? Yeah, girl, that's what it is. Okay, so this means that a pumpkin is an outlier on the lower end if he weighs less than -9 pounds. Is that even possible? No. So there are no lower outliers, and that makes sense to me because look at what I originally thought. I didn't think anything on this side was an outlier. Why? Because it's all so close. It's all just together, all clustered together right here. So it makes sense to me that my lower bound would be a negative number and that there were no outliers because it doesn't even look like any of them are outliers. So now we're going to do the other end, the upper bound. This time we take Q3, 12.7. and we add 1.5 times IQR what'd you get? 25.75. And I realized as you were doing this that these are not the same data. Teacher, why are you referring to this one? But if you look at these, it's the same. Like if you look at your lower end, all of these values are very close. 2, 3, 4, 5, 6, 9. And then it starts to jump to 15, 31, 33. So did we end up having some outliers? So look at your pumpkins. Did any of them weigh more than 25.75? Yeah, 2 of them did. These 2 on the end, 31 and 33, those are legitimately, mathematically outliers. Those guys are really heavy. I probably wouldn't even be able to lift it on the table. So we're going to say 31 and 33 are outliers. You can say outliers equal 31 and 33. You could say outliers colon 31, 33. It's whatever you prefer. You're hanging in? Yes? Okay. Now let's go back to the caffeine data again. This problem on part C asks you to describe the distribution, which we don't know how to do yet or haven't formally talked about. But it also asks, are there any outliers? Use 1.5 times IQR rule. So since we already found the quartiles, let's go ahead and take a couple of minutes to see if we can determine if there are any outliers in the caffeine data set. So you guys have everything that you need. You have the quartiles right here to calculate your lower and upper bound. Okay, try it without me though. If you're at home, you be trying it too. Everybody try. I'm not going to pause the video, I'm just going to let it roll. Okay, I'm going to come around the mountain and see how far you are. Okay, I ran out of space, but I wasn't paying attention to when it stopped. So if you're missing a bunch of information, I apologize. We determined there are no outliers in this data set, and I was just mentioning that that makes sense because if you look at the shape of this data, it doesn't look like any of them are far away from the data, and there's no gaps in the data, so I think that that makes sense that we wouldn't have any. Okay, so we're going to finish up then with the teacher shoe data set. So we're finishing up with this bottom example. This is the last thing that we're doing today. So I already kind of gave it away because I confused this with the pumpkin problem. But if we just look at this data before we go through and actually calculate, I don't think that there's going to be any outliers on the lower bound because that's where most of the data is, or on the lower end. But I'm pretty sure we have some outliers on the upper end. Now, this is 52 observations, which I don't necessarily want to have to order and count and find the quartiles and everything for. So I'm going to show you the shortcut of how to use your calculator. Unless the problem says, do this by hand, you can use your calculator to find the quartiles and the median from now on. So there are a couple problems in your Can You Do that say, do it by hand. I'm going to give you the buttons and then I'm going to show you, I'm going to do it in my calculator. So first you have to enter your data, which is why I had you do that previous to this. Then you hit Stat. You arrow over to Calc. That's short for Calculate. And you are going to choose option 1, which is called 1 var stats, which stands for 1 variable statistics. We only have one variable in this data set, and it's the number of shoes owned, or the pairs of shoes owned. So for any data set, this is how you can get all of these values without having to order them and find the medians. So we are going to go to our calculator, and it doesn't matter what screen you're on. We're going to hit Stat. He's next to the circle of arrows. We're going to arrow over 1 to Calc. We're going to hit the number 1 or Enter. Then you're going to change your list probably to whatever list you put the teacher shoe data in. Mine's in list 6. To change your list, you just hit blue button and whatever the number of your list is. You hit Enter. We don't ever put anything in frequency list. Enter, Enter. And then it gives you all of the statistics that we're interested in. We haven't talked about the first 4, or 5 actually, but this is telling us that the average number of shoes that the teachers own is 22. Our quartile 1 is 10. Our median is 15, and our quartile 3 is 26.5. So let's write those down. Q1 is 10, median is 15, and quartile 3 is 26.5. So now we're going to use those values to see, were those points above outliers? My IQR is 26.5 minus 10, so 16.5. My lower bound is Q1, 10, minus 1.5 times this IQR of 16.5. pretty sure that's going to be negative. Anybody get it yet? Georgia? I think it might be a little lower than that. Negative 14.75. I'm getting 23. I must have plugged something in wrong. I'm just going to double check mine. Will you guys find the upper bound while I'm double checking mine? Yeah, you guys were right. Negative 14.75. Upper bound? So if the teachers owned more than 51.75 pairs of shoes, they are mathematically an outlier. So I go up here, and all of the ones that I was considering end up being outliers, even the ones that I just thought maybe. Yeah. Oh, 2.5? Thank you. So on this one, we are going to say there are 5 outliers. And then I'm just going to write a colon and then say 54, 60, 85, 100, and 102 are all outliers. And then I need to tell you one more thing before you clean up, so hang tight. I'll go fast, I promise. We still have 4 minutes. Okay, so I remember from the one variable stats that the average for this data set was 22. So that's like right here. The average was 22, but most of the data is below 22. Notice that the median, though, is 15. If I go to 15, that's like right in the middle of where most of the data is. So which one is a better description in this case of the amount of shoes that teachers typically own? Median. Median is a better description of how many shoes the teachers own. Grant? You were just answering. You guys feel okay about this? Okay, I want you to check the module later tonight or over the weekend to see what your homework is, because I haven't decided yet. I feel like we might need a break, but like, I don't know, because maybe I'm just tired, you know? I'm tired. Okay, distance learners, we're done. Love you. Hope you're doing well.